In this video, I want to provide an introduction to problem set 4, which is going to be covering the concepts of how we actually go ahead and estimate weighted least squares models, and also how we go ahead and do IV estimation in the event that we have endogeneity. So, like all the other problem sets, there is going to be a practical element, and this practical element here is going to be inviting you to investigate the various factors which affect an individual's wage. And in particular, we're going to investigate what actually is the return to education, so the number of years of education. And the reason I've used this example is partly because of the fact that we've used it as an example in a lot of the videos. And it also provides quite a neat example of both weighted least squares and IV estimation. The data here again comes from Professor Waldridge. So thanks very much to him for making this data available. The data is strictly from the study which was done by D. Card in 1995. You can see the link to this particular paper within the problem set itself. And I actually encourage you to read this particular study which was done because it was a very strong study and a good use of instrumental variables. At the end of this practical element, there is also a freestyle element, which is, in this particular example, inviting you to estimate what you think is the return to education. And unlike some of the other problem sets, there isn't necessarily a strict right or wrong answer here, and there are a range of values. So I expect that a lot of different people will get different values for this, and it might be interesting for you to go ahead and compare the return to education which you get from your model with the results which were achieved by Card in 1995. As with all the problem sets, there's also a theoretical element here, which is going to be looking again at weighted least squares and IV estimation. I should mention here in this practical element, even though we're going to be estimating weighted least squares models, technically they fall under the category of feasible generalized least squares models because we don't actually know the exact weighting beforehand. We actually have to estimate it because we don't actually know explicitly the form of the heteroscedasticity which is present. And then finally, like all the other problem sets, I'm providing my own written answers to each of the questions here. So you can compare your answers to those answers which I've achieved, and I very much encourage you to provide any sort of feedback on how you find this particular problem set. But hopefully you'll find it a fun and a nice way to practice some of the skills which you've learned in the class.